we often want to merge data frames whose columns have natural orderings, like date-time columns. This is the domain of ordered merging. Let's explore this now. We start with data frames of sales from a company that sells software and hardware products. We make sure the data frames are sorted by their respective date columns using the sort values method. When we examine the data frames, software has 9 rows and hardware has 5. Both have identical column labels: date, company, product, and units. The date columns of both are sorted chronologically, and the indexes are jumbled ranges of integers. Attempting to merge yields an empty data frame because it is actually doing an inner join on all columns with matching names by default. In particular, the units and date columns have no overlapping values, so the result is empty. If we do a merge with how equals outer, the result is no longer empty. We can also sort by the values in the date column, giving a nicely ordered data frame. This is what the pandas function merge ordered actually does. It behaves like merge when columns can be ordered. The merged data frame has rows sorted lexicographically according to the column orderings in the input data frames. Be aware, however, that the default join for merge ordered is an outer join, contrasting the default inner join for merge. Like merge, the function merge ordered accepts keyword arguments on and suffixes. Here, we select only the date and company fields for merging, and we provide suffixes. The function merge ordered also supports filling null values. To illustrate this, let's load some monthly stock data from 2013 into a data frame stocks, and some quarterly gross domestic product data from 2012 and 2013 into a data frame GDP. Notice GDP has 8 rows, while stocks has 12. All date entries correspond to the end of a calendar month. When trying to do an ordered merge on both data frames on date, the date columns have different frequencies, monthly versus quarterly, over different intervals, 2013 versus 2012 and 2013. The resulting merged data frame has many NaN entries from the mismatched month ends from each data frame. Specifying fill method equals ffill as an option in calling merge ordered uses forward filling to replace the NaN values by the most recent non-null value. This fills in the gaps in the GDP data, but the null stock values from 2012 are unchanged. Forward filling does not help much when the entries at the very start of a time series are null. Now it's your turn to experiment with merge ordered in the exercises. You'll now apply your skills with combining pandas data frames in a case study. Does a country win more Olympic medals when it is the host country? To answer this question, we have a collection of flat text files from The Guardian containing a summary of country codes used by the International Olympics Committee between 1896 and 2008, a description of all the editions of the Summer Olympics over that period, and a collection of CSV files detailing medals won in individual sports for each of the corresponding Olympic editions. To start, you'll load the data from the relevant CSV files. You've used the pandas read CSV function a lot by now, with many of its optional parameters. You've applied loops and comprehensions to process many files efficiently, and you've combined data frames through appending or concatenating. Have a go now with the first exercises to get the data ready by loading and merging the datasets. You've now created a set of data frames that represent the raw Olympic medal data. The data frame medals describes each athlete who won a medal in each Summer Olympic edition. Do some analysis now to quantify how well each country performed. You can use a pivot table to find useful patterns in the data. Remember, the data frame method pivot table requires specification of the index of the table, the values to aggregate, the specific aggregation function, and the categorical columns for grouping. The resulting pivot table will have the Olympic edition on the index and all the country codes as columns. The entries will be the total number of medals awarded to each country in each year. Since most competing countries fail to win medals, most entries are null. You'll then need to normalize the number of medals won using the total number of medals awarded in each edition. This number obviously varies from edition to edition. Once the data is normalized, other trends can be quantified. Go through the next exercises now to extract quantitative measures of country performance from the Olympic medal datasets. You've now built a data frame containing the percentage changes of each country's fraction of Olympic medals won. To get an idea of the trends, You now want to melt or reshape the data to make it easier to work with. You'll also need to integrate the host country data into your analysis. You'll merge that information into a new data frame using other data frames from before. You'll execute another merge to yield a data frame that quantifies the influence of being the hosting country on the percentage change of the fraction of metals won. Finally, you'll summarize these values in a bar plot. If the plot shows large positive changes systematically, then you've gathered evidence to support the notion of a host advantage. Finish up your analysis now in the final exercises. Congratulations! You've made it to the end of merging data frames with pandas. You've learned how to load and manipulate data files programmatically. You've become adept at working with pandas indexes to get the most out of series and data frames. You've mastered concatenating, joining, and merging data frames in numerous ways. You put all these skills together and took a deep dive into the Olympic medal dataset. The skills you now have provide an excellent foundation for your future data science endeavors. Well done!